Before I begin, I quickly want to thank the BitCamp 2025 team for organizing this event. And I'm really glad to be part of this event. And I've really enjoyed what I have made and the support I got during the past 2 days. So thank you very much. And that's it. I mean, yeah, let's move on to the formal presentation of this project. So, hi everyone. My name is Akshat Dharmesh Patel, and the dashboard you see is basically SnortEduGuard dashboard, which is a production grade real-time academic intrusion detection system. So, I want to give you a backstory, like why I have created this. So, as a teaching assistant, I have personally seen how students rely on AI tools, Course Hero, Check, and VPNs as well, sometime during assessments. Assessments as in quiz, in-class exams. So, despite warnings to stay on Canvas or Google Forms for the exam, many find way to access the AI, ChatGPT, Discord, and Chegg, and Course Hero, and whatnot. And do we have any solution for it? I would say traditional solutions, like I mean, we do have, but traditional solutions like lockdown browsers are not enough. So I have built something like I have built a tool that detects and alerts on unauthorized digital behavior of students during exam, ensuring integrity in the classroom. So before I even begin giving a demo, I just want to run one script which will initiate this knot and it will start capturing the packets. So there is a script I have created which is start_fresh.sh. So what's inside that? Let's check. So basically there are three commands it will run. First is it will remove all the existing logs inside alert.fast. Then it will again remove all the logs which are I just want to check if I'm recording this or not. I guess I am recording. Okay. So second, it will remove all the logs which are stored in the parsed_alert.json. In simple words, logs which we captured in the JSON format. Third is the command which will initiate this knot. It will give Snort an idea of what to do and where to store the alerts and in what form. So I will give you a more idea of those two type of log files, but just to give you an idea of what they are. So when I run the Snort will capture the network packets according to the rules I have created. Those raw alerts will be stored in the alert.fast file. It's very raw. It is unreadable. And for that reason, we need to do something with it. And for that reason, I have created a parser. It's again a script which is again looking for logs in the alert.fast. It will parse those log and convert into JSON format to make it ready for the dashboard. So that's a brief overview of that. Let's run that. Um, so basically cleaning old logs, starting snort fresh, and asking for my password. So as you see, I have here a terminal which is continuously on every 5 seconds giving me an idea of how many logs are parsed, how many logs I have in the parsed file, parsed log file. And just to generate some legitimate traffic and to detect few alerts, I have few few commands ready. That is the first one. This is to actually access the chat GPT. We can just paste it and hit enter. It will mimic that I have accessed the chat GPT, but we can also go to browser and write chat GPT. So in this way, we can search for many websites like Chegg, um, give it a refresh, open Course Hero, and like that. But it's a lot of manual work. Um, so I have just created a file which have all the commands directly. We can also check for OAI. So basically, I'm just running and accessing multiple sites to create some legitimate traffic. We can also search for Google Gemini, then check. We just did Course Hero. We can check for Quizlet. Then we can check for, let's say, VPN from. Okay, so my system is also capable of detecting VPNs. If any student is trying to connect to a VPN, I will get a notification in my system that this IP is trying to connect to a VPN. So the system is capable of doing that as well. And just to verify, we will be seeing all the alerts generated based on the rules I have created. So just bear with me and for some time until I generate some traffic. These are few communication channels like Discord, Slack. So let's do some Discord call, then Slack, and yeah, for ICMP traffic, we can just do a ping to Google like this. Then then we can try to access Canvas as well. We can either go from here or we can just go to Chrome and write Elms and log in. So yep, I think this should be it. So we have created some good traffic. Let me just give you what again we are doing. So before I begin, let's see a architectural diagram, which is this. So let's walk through the architectural diagram until the dashboard is getting all the logs in it. At the core, we have a snort3, which captures new packet level traffic and logs alert into alert.fast file. This is the file which will store all the raw logs from the alerts generated on the base of rules. Then there's a Python daemon, which is named as parse underscore alert.py. So it is like this file, this Python code, a script, which I have wrote. So basically, this Python daemon watches and parse these alerts in the real time into structured JSON format, which is very important for the dashboards. And the structured output, that is parsed alert.json, powers a fast dashboard with auto refresh visuals, CSV, PDF export, and smart filtering. Yes, you heard it correct. So that dashboard is capable of auto refresh, visual charts, CSV, PDF export, and smart filtering. I'm talking nothing else about these this dashboard. So this dashboard, as you just see, got refreshed by itself. We have beautiful like chart given over here, and the distribution, alert distribution by priority. So we have four different priority distribution, that is 0, 1, 2, and 3. You can refer to them as a level. So 0 is nothing but zero level alerts, like basic information alerts like ICMP, ping, something, something. Then the first level is I would say the first priority. First priority means if someone try to access Quizlet, any AI tool like ChatGPT or Terp AI or Gemini, so those will be considered as a priority one. Then second priority level is the medium level, and the third is low priority level. As you see, there's a huge difference between the alerts in all the four different priority, and this means that there's a traffic which is not, I would say, um, those that traffic is correct, but it doesn't contain any searches of AI and all. It's just basic communication with the internet via cookies stored in the student's browser. So we just need to focus on the first um, priority level. There is a feature of download alert as CSV, export PDF report, smart search. So if you click on download alerts, it will directly download all the existing logs into a CSV file. Then if you click on export as PDF, so this may take time because it takes time to generate report. So it will create a report and it will give all the alerts and report into a PDF form. I guess it's downloaded. Yeah. Okay. And there's a search option as well. Let's say as we created some traffic for ChatGPT, Terp AI. Oh, okay, let's also generate some traffic for Terp AI. So I just access Terp AI. I guess this should be good. But just to make sure, I'll do it again. And I guess this should be it. So after some time, we will have some logs which will say that I have accessed Terp AI. So let's check for ChatGPT first. Oh yes, ChatGPT. Yep. I got some log with timestamp. So it got refreshed again after a few seconds. So we need to be quick. ChatGPT, then Quizlet. We access Quizlet as well. That's why. Then let's try for Course Hero. Yeah, we have the Course Hero logs as well. Then we can search for VPN service. Yeah, we have logs for NordVPN, Proton VPN. So our system is working pretty fine. So now I have idea of what what IP has searched for what particular web application. So let's think of a scenario. Let's say I'm a TA. I want to take a quiz in a class which have around 100 students. So I will decide a range of IP addresses and will design a subnet. Like I will decide the subnet after that, and I will monitor that particular range of IPs. And IPs won't change over a network until unless someone uses VPN. And we can also detect the VPN access as I just showed you. So if someone tries to connect to VPN, I will have logs and the original IP, so I can always go back and check the laptops for the original IPs, and I will know what device accessed what. And in this way, with the help of source IPs, I will be able to filter all the students on the basis of their activities. I'm going too far, I guess. So let's just wait for some other. Let's discuss some more topics first. So I mean, we have some, the third part is detection rules. So I manually wrote over 40 custom snort rules using TLS SNI inspection to detect cheating tools, Gen AI, and use of more bypass methods. I covered AI tools like ChatGPT, Bard, Claude, Top AI, U.com, Perplexity, and even Po.com. So even the small AIs I have tried to cover in my project. Then I have covered study sites like Chegg, Course Hero, Quizlet, and then StudoQ and Brainly. And then VPN services like NordVPN, Proton VPN, and Siphon. I also try to focus on collaboration apps like Discord, Slack, and WhatsApp. So I even have rules for detecting Discord, Slack, and WhatsApp web connections. So I added rules. So I mean, I have even added rules for DNS to detect DNS tunneling, HTTP beaconing, and Nmap scans, which shows how this system could scale to network security beyond just bitmap, like Bitcamp. I just want to show you like local rules. So for that, we will need to go to sudo, then user, then local, then etc, then snort. Let me just grab it. Yeah, then snort and inside rules, and I mean, yeah, and this is wait, sudo nano, then local rules. So these are the few rules. Yeah, and if we go to this path, ah, I have created multiple directories for different rules, like for AI, for allowed rules, C2 rules, cheating rules, collaboration tool rules, local rules, Nmap rules, VPN rules, and I also wrote DDoS, which I have not integrated yet, but I will definitely do it while demoing in the real time, which is tomorrow, like today, I mean. So like this shows my passion for cybersecurity, deep protocol inspection, rule engineering, and network awareness, not just UI tweaks. So yeah, I want to keep this precise. So I'll just skip to the next part. That is fourth, log automation. Snort, as I said, as we discussed in the beginning, that Snort writes logs to the alert.fast, which are unreadable by default. But my parser script, which is parse_alert, um, parse_alert, this script is capable of, like, which it uses regex and extract timestamps, SID, priority, protocol, source destination IP, and in the end, it saves all those as a structured JSON form, which is again parse_alert.json file. So again, this is something which we discussed in the beginning. That is, we have two log files, one for the raw data and the second one for the JSON formed logs. So this, the parse_alert.json file, basically parse underscore, I mean alerts. So this is the file which is responsible for all the alerts or the dashboard we see. And this actually drives the whole dashboard. And this automation ensures snort alert flow continuously to the front end. No manual work is needed. And I want to give you one thing, that as you see, the logs are coming in burst form and they're not coming line by line. That is, I'm getting the logs or the alerts in the batches. And this is because of T, which is TEE logging, T logging. So T logging basically introduces a small delay, and that's expected due to the buffered STD out. So that was it about the log automation. Now let's move to the fifth part. Fifth part is nothing but dashboard features. So let's move to the dashboard. I want to stop capturing the traffic now. It's too much. So, and we have enough traffic. So let's move to the dashboard. So this is the SnortEduGuard dashboard. It refreshes every 10 seconds. Each alert is color coded by priority, and we can also download all the alerts in the form of CSV or either PDF as a form of report. We can search things by keyword, and we can also see the real-time spike in the logs or alerts and in the order of priority, which is 0, 1, 2, and 3. 0 is nothing but a general information alerts. First is the first priority alert, second is the medium, and the third is normal. As we see, we have 19 high priority logs, and those basically will have like access to generative AI, course supporters like Course Hero, Quizlet, and more, access to VPN and all. So this will give an instructor or a TA like me a brief idea of what is happening in the exam, like what tools are basically getting accessed, and I can have a quick overview here. Um, then we have whitelisted domains like umd.edu, canvas, instructor.com, zoom.us, which appears gray out but still visible. So instructors or the TAs know when legitimate platforms are accessed. And I have also built an instructor login system, which is a beautiful branded login screen. I will show it in a second, but I can also show you the logs of canvas access like this. So we tried to access the Elms a few minutes ago, and which is visible here. So that is whitelisted, and all the other information which is not relevant, which is other than Elms and the Google form, is tagged as unclassified, which is very readable, because reading all the different logs might be tedious, and just reading unclassified non-relevant logs best. Let me show you the login page. So this is the login page which I have created. It's instructor login. Welcome to the SnortEduGuard Student Integrity Surveillance System. my username, password. So I'm not the only one who is going to use this tool, right? We have multiple TAs. This is a very big university, so everyone needs their own separate customizable dashboards. So I also have a like database which stores the credentials which are encrypted and are unique for everyone. And this is developed by Akshat Damesh Patel, which is me, and small personal branding, my portfolio website. um, yeah. So let's try to log in. So my login is for instructor, and my password is hit login. So this is the dashboard I can see, and it's pretty interactive. And I mean, yes, again, after the Damesh Patel, personal branding, the name of my tool, University of Maryland, Bitcamp. But wait. This is not it. We have something more. I have something more, which is part 6, smart search. This button. So now here is the real wow factor, smart search, an AI-powered natural language interface that transforms how instructor analyze logs. So let's say I type something like show VPN access in the show VPN access in last 30 minutes. Wow, this is great, right? So this IP, basically, which is me, may be using a VPN because I tried to access NordVPN and Proton VPN, which we verified in the logs as well. It also gives me a time, exact time at what time I tried to access the VPN. And we can also check like show ChatGPT alerts in last 30 minutes. So boom, again, I can see all the logs for with time, with source IP of when I tried to attempt ChatGPT. So this is something like great for me as a security analyst, as a security enthusiast. I have for the first time in my life tried to integrate NLP in this way. So let me give you an overview of what is happening. So let's say, as I said, I typed something like show ChatGPT alerts in last 30 minutes. So this isn't just a search. It's a question a human would ask, but the system understands it. And here's how. First, I built a custom NLP parser, which is parse underscore query, which is parse underscore query dot py. So, and I used Spacey, an open source NLP library, which which loads the categories and stuff. So I loaded the Encore Web SM, which is a English model, and used that to detect keywords like VPN, Chegg, AI, and Zoom. We just as we just saw in this file, we have different categories for AI like ChatGPT, Bard, Claude, Anthropic, API, IAM, and stuff like that. So it's because of Encore Web SM, which is an English model again. So instead of hard coding filters, the system intelligently extract the intent of the user. Next, the parser intent gets parsed and with the help of smartfilter.py, um, which is which is this. So the the parser intent gets parsed to this filter, this smart underscore filter script, and that script reads through the snorts alert.fast log, matches the relevant alert based on the time, range, and category. The return filter structures data. And then comes the AI part in the summarizer.py. So I have this summarizer .py. So this is the summarizer.py, which I use custom logic with Python templates to timestamp to convert raw logs into human readable summaries. And that is why we are seeing something like this summary. And that's much more readable than showing snort raw format, right? I mean, what we just saw in the what the logs which we saw like this are not that readable compared to what we are seeing here. So all this happens in real time on the smart search route of my Flask app, and the user just asks, and my system does the parsing, filtering, and summarization, everything automatically. And that's the beauty of this whole project. Um, so let's move to the next part. I would say the second last part, I guess, which is security engineering. So SnortEduGuard reflects real-time world defense in depth. So I used passive monitoring, default deny modes, and layered visibility to track what students try to access during assessment. Like I even supported exam mode. So exam mode, let's say, let me show you example. Let's go to the logs. I had the rules, but let's try to open in a cat form. So this is the whitelisting first mindset. Don't okay, ignore that comment. It's just for me. So let's take an example of this. So I even support exam mode, which flags any HTTPS traffic not matching Canvas, Zoom, or UMD, and it will just give unclassified, non-required traffic. So, which is something which is required in the exam mode. If something is running in the background in the student's computer, that is fine. But if any major web application runs, the system is capable of detecting it, logging it, and giving a brief summary to the instructor. And if we implement this in the real life, it's going to be a game changer. And the last is conclusion. So, as I said, Snort EduGuard is scalable, production ready, and built for the modern classroom. It blends Snort deep packet inspection with automation, AI, and smart dashboard. So I would like to thank Bitcamp, and I hope this helped secure my classroom and might be your classroom quiz. That is it. Um, I think I have covered most of the stuff, but just to make sure, my that dashboard is running because of this terminal, and it's nothing but a simple script again, which is app.py, um, which runs the whole dashboard. And in this way, I would like to end the simple demo, and I hope you enjoyed. And I'm excited to show this in the real time today at around noon. I'm not sure. Wish me luck. And thank you so much. I'm stopping the recording. See you all. Bye bye.